Hello everyone, it's September the 4th. Alright, so the heat wave hits. It's actually quite warm right now. Have to keep the fan on, otherwise it's going to be a long night. Watch the movie today. Escape from Alcatraz. I plan to go there this weekend. So it's good that we did some homework beforehand. Alright, today's goal is we're going to solve this one for sure, and we're going to go to the solution to yesterday's problem, to this one. I mean, our solution is all right, but I feel just a little bit, how should I call it, convoluted. So I want to see how other people solve that. So that's today's goal. Go for it. N array, tree level, order, traversal. Oh, binary, trinary, n array, not n array, n array, right? N array tree to the level order traversal of its nodes value. N array tree input serialization is represented. I don't need to know the serialization. I just need to know what we want to return. Huh. Isn't that just a BFS? Yeah, that's just a BFS. So we have a, shouldn't be that hard. Hold on. Did we say this? We did. That's for yesterday. Alright. This one shouldn't be too bad. Let's get to it. What do we have? Q. Alright. Rest. I'll put a root in here. A list of int. That's what we want. Okay. So while Q temp for node in Q rest.append. Ooh wee. Temp. Rest temp. Right? I can just do rest.append. There we go. And then we can say rest-1 append node.val, right? And then for child, the node.children temp.append child. If child, right? Temp.append child. And I will go through everything. As we're done, we are going to say Q equals temp. And return the rest. I'm pretty confident in this, so let's just give it a shot. And see if it works. Unexpected indent. Oh, we have an indentation here. No idea. Try again. Yeah, should be right. A year ago. My. I probably should put it here. If node. And then we just put it in there. And this one shall handle this as well. Oh, holy crap. Huh. I should do it at the beginning. Not node, not root. Turn this and everything else is fine. Yeah, and I want to return to the original one. If not root, return this. Otherwise, we do this. The original one is right. The only thing we don't have is to check on the root. There we go. Yeah, nothing. This is just a basic. Well, maybe I had 2 problems today. 429. Basic DFS. Alright. That's that. Let's see. Oh, interesting. Less than 20, yes. Tens. Oh, did you see that? Did you see that? Thousands. Ah. Thousands I. What is I? Thousands. That is fine. Now you do this to get. This looks cleaner, right? I see. Let's redo this. Write it slightly better. We can do this. Below 20. Yeah. We'll turn this into an array. Okay, so 0 all the way to, but that's fine, that's below 20. And then we need to get tens. Yes, exactly. Tens. Multiple of tens. So there will be this, then 20, 30, 40, yeah. 0, 10, 0, 1, 2. Okay. Then we use one helper function, def convert. Right, so self num, and go int, and then return as here. Right? So num will be at most 3 digits. Num is at most 3 digits. Okay. So if num is 0, that one is 0. That's the only time 0 will happen. Right? Then what? Then we're going to say while num. Right? So we'll say result. Look at this. Then what? Look at the last 3. Right? Look at the last 3. And you get the remaining. div mod. So we're going to say num rem equals div mod num and 1000, right? The remaining will go to convert. And then we can say words equals self.convert rem remaining, and then I do need levels. Okay, then we say res equals words, right, plus f string. So words is levels dot pop plus result. Right? It depends on what the words is, right? Yeah, it depends on the word. They have to check too, right? I mean, they handle it there, so we can try that too. Let's say words handles everything. If words handles everything, but you still need to consider this. Alright, what if there's no thousands? What you gonna do? I have this thing. Nah, I don't like it. So what I will do is if remaining, right? Then we'll do this. And words will handle everything for me. So I just words level pop. And of course, if there's no words, no rims, no words. So this is perfectly fine, right? And then keep going, and at the end I will return res.strip. Right, we'll have to strip no matter what. Okay, so now we just need to handle convert. Alright, say if num equals 0, return empty string, right? If num is smaller than 20, we'll return less below 20. Below self dot, below 20 num. We can do this, right? If else, then we'll do 100. Let's say if num is smaller than 100. Self dot multiple of 10s. Oh, Jesus. multiple of tens. That shall be the first one, right? So it's num divided by 10 plus self.convert. All right. I think we need to have this. Else return self.convert num no plus self.convert num plus this. All right, let's try this. Maximum recursion. How? I don't understand. Second one. 1 and 23. That should be 123, right? Yeah, it's 123. So we convert 123. 123 no, so we 123 divided by convert 1, which shall be here. Ooh, I already handled it, so I don't have to handle this anymore. Then 123, that is 123 again. Holy crap, I think that's 100. Yeah. Oh, and then this one also handles. I don't have to handle this again. Oh, then this one handles, so I don't have to handle this again. Yeah, I handled here. Pretty sure I don't have to handle this. 123. What is 100? You need to have 100. Unless, well, that's larger than, so yeah, it's fine. Plus 100. Alright? 100. Oh, I don't have that here. Yep. Alright. 10 million. 10,000. What? That is interesting. I passed every single one except for this one. Oh, I did not pop. Level. I have to pop every single time. I don't need to use it, but I have to pop it every single time. There we go. That inspired by this one. With recursion, the logic is cleaner. Definitely. Absolutely agree with this. Upvote I don't think I need to check this. Yeah, that's okay. We got this. I actually like this solution. It's clean, it's pretty good. Of course, run these codes just to be sure. Nice. It's faster. I think just less if and else. Like here, you just have so many if and else. Oh, and I will do this. I think it's the splicing. This doesn't have splicing. We're using a mod. I think using arithmetic to get 3-digit numbers is faster than string splicing. Just a hypothesis. Okay, we're done with this. We can pick one. Most likely, when you pick one, you'll pick a medium one. Oh, you get an easy one. Do we want to do an easy one? Might as well, since I've not done it before. Yeah, I can do this. A valid parentheses string is either empty, this, or a plus b, where, for example, that's fine. A valid parentheses string is primitive if it is non-empty, and there does not exist a way to split it into a plus b. Okay, that's primitive. Given a valid parentheses string, let's consider its primitive composition, okay, where pi are primitive valid parentheses strings. Return s after removing the outermost parentheses of every primitive string in the primitive decomposition of s. So for this one, exactly, these two are primitive, right? So we need to first get those into, and then we remove the outer. So what? We need to get to the primitive first? Yeah, I think we need to get to the primitive first. Well, how do we get on the primitive? If we get to yeah, every time you start a new left, when the stack is empty, that's the decomposition, right? So what you want to do is, when you start, you have the left parentheses, right? And have a left parentheses again, and you have the right parentheses. That is a thing, so this one should be put into some stuff, and then you keep going, put into stuff, put into stuff, and then when you hit a right parentheses, that is a primitive, right? That is a primitive. we do only one level. Yeah, we're gonna do one level. So that's why it's easy, because we want to do one level. So we hit the right and the left, we don't care. And then we hit the left, and then we hit the right. Okay, then we pop those. We hit another one, we pop those. We hit another one, we pop those. Yeah, those are considered together. It is whenever we hit another left parentheses, that's a new thing, right? That's a new primitive. So we'll do whatever we do, and the first time we hit, yeah, so we keep that. How do we keep that? We can pop, 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 pop. Then we hit here, and we pop, and we hit a left parentheses. When we hit the left parentheses, whatever is in front of it, right, must be a primitive. So we know what that is, okay? And what we want? We want to strip the outermost primitive, right? Which means we just go until we find one that can pop the first left parentheses. Right? Once we find that, then we have everything inside, and everything inside should be left intact. Everything inside should be left intact, and that shall be in the result. I think I know what this one's looking for. Yeah, it is a little bit confusing, and I might not call it an easy one. Yeah, I think I will not call it the easy one. Solution is not immediately obvious. That's usually the definition. The easy one, solution should be very straightforward. But this one is, I mean, all right. So what we want for I, letter in enumerate S, if we say if letter is equal to right, then stack pop pop and stack. Oh, it's valid, so we should stack and we can pop. As I say, it's all valid. S is a valid, yeah. So we're gonna pop, right? If it's a left else, if it's a left one, then we're gonna push it in. But at the same time, we are going to, so we're going to push in, we're going to check if there is anything in it. Right? If there's nothing in it, actually it's pop. When we pop, the result, right? Then we say J. Yeah, I might use J here, use I here. We say I equals this dot pop. Right? Now we say if not stack, then what we have is the first outermost. Then rest plus equal to S I plus 1 to J. Else stack dot append J. So we do this and then return rest. I'm pretty sure this is what they're looking for. A little cryptic for sure, but overall it's fine. It's not too bad. Now if I got it right, then it's not too bad. But if I didn't get it right, I am not gonna be happy. Let's see. we'll see. What's this? S. Remove. Yep, I think that is what this one is looking to do. Just remove the outer one. There we go. If I don't like it, I can see why. Yeah, it's not difficult to code the solution, but it did take a while for me to understand what the problem is asking for. Basically, it just wants to decomposition, right? S, and remove the top level outer parentheses. There is no recursion because we are only interested in the top level, right? In the top level. All the inner level parentheses shall be left intact. Let's see how people react. I'm not sure people like this. Count open. That is true. Yeah, because we just don't count the first one. And then if we have one open, just keep adding. Now we have this, we have 1. Then if it's not 1, because I minus equal 1, and we hit this, it's not larger equal to 1, only 1, then we don't. Yeah, that's true. I mean, it's similar, but we do have this, which makes it slightly slower because we have this. Yeah. Let's code the other one. Open and closed. We only ignore the parentheses, right, of the first this and last this in the decomposition. This means if we keep track of the number of open paren, then we ignore this if there is no open paren at the moment, that is the current. This is the first left parenthesis. Similarly, we ignore this if there is only one open paren. That is, the only open paren is the first. This. Yeah. So we don't even need a stack, right? And the result can be, Yeah, it likes to use this. So I just need to say open. Right, open is going to be 0. Open paren is equal to 0. And I just use this. I don't even need to enumerate it. Right? I say if is equal to this, and open paren is equal to 0 is actually larger than 0, then rest plus equal to letter. Now if letter is equal to this, open paren is larger than 1, because if it's equal to 1, now we skip. If it's larger, then we do this. Right, once we're done, you say open plus equal to 1 if letter is equal to this, else minus 1. And then we return rest. Very good. Good solution. Open and close. That's one of the tricks to use open paren and close. Keep counting. It's similar matter. So are you saying that by changing this into this, I don't know, are you saying it's going to be faster? Not sure. Try list join, see if it is faster. That's alright. Alright, that shall be it for today. See you guys tomorrow. Adios.